Hey, hi everyone. Good morning. This is Shrikant. How are you doing, guys? Am I audible?
Yes, sir. Good morning.
Good morning. So, guys, how was your Python classes? So, any comments? Anything you would like to discuss before we move into the subject today?
Sir, a small thing not related
Yeah.
to subject, but about the timing.
Yeah.
Uh, we need to fix some time, sir. I feel like 8:45 or 9 because we have been waiting every day at 8, it's at 8:45, and sometimes it is at 8:45 and sometimes it is at 9.
Okay, so we have to fix. So, what is convenient for you?
Yeah, I feel
8:45 or
it's
9?
9. 9.
Okay, so we'll fix it at 9.
Okay, sir. Thank you.
Okay, thank you. All right, so today we are going to discuss about statistics. I think Vikrant has kind of touched upon that subject, okay, yesterday. Yeah, but we'll start from the scratch, okay, from the basics, so that you can understand what the statistics is all about, okay, and why is it important, and what are the basics of statistics, and from there, we'll pick up, we'll move forward into advanced concepts of statistics. Okay, so when you hear this word statistics, what comes into your mind, guys? Okay, what do you think the statistics is all about? Anybody? And knowingly, unknowingly, you guys probably you have used and you are using statistics uh, some or the other way. Uh, but when you hear this word statistics, what comes into your mind? Don't be shy, okay? Anyone, please.
Some calculations on existing data.
Some calculations on the existing data. Okay. Okay, so if I put it like this, okay, what do you think? What is the difference between statistics and mathematics? Now, what you'll say? What will be your answer? See, consider that I'm taking your interview, guys. Okay, now you may face this kind of situation during your interview. Then, how will you try to respond to these kind of questions? That's something I want to see. Okay, and that's where I will give you some feedback. Okay, I can give you certain tips and tricks. Okay, so take this as an opportunity and try to speak out. Okay, and that would even help you out to gain some confidence. If you see, sometimes what will happen, you might be thinking right, but you will have a fear that I may go wrong. It may be a wrong answer. Okay, and you will not speak. But when you hear the answer, somebody else giving that answer, you'll say, man, this is what I was also thinking. Okay. Generally it happens, right? So I'm saying whenever you get a thought, just say it out. While saying, there could be a chance that you may not articulate it properly. So there I can help you out. Okay. So if you're not confident, then how you should answer. If you're confident, then how you should answer. Okay. That's something you have to understand. Why is it important is you may learn everything. Okay. You may learn, you may put all the efforts, you will be serious in what you are learning. But when it comes to interview, probably you may fail. And you will feel that and you will get frustrated by saying that, okay, I have put so much of efforts, I have learned so many things, but still, I'm unable to crack the exam. So I would say that gain that confidence of responding to the question. Okay. So yeah, so generally everyone might have heard about this word statistics, right? And definitely everyone will have some or the other opinion about this word statistics. So my question is, what you're thinking about statistics? What you think about statistics? And yes, you don't know everything about it. That's the reason you are attending this course. So don't shy away by saying that, okay, I don't know. Or if you know, if you have any idea, then explain me. Okay, tell me. Okay, what is statistics? So someone said that it's all about calculation. So then my next question is, subsequent question is, then what is mathematics? Then is there any relationship? Are they same? Are they different? If they are different, then how they are different? Go ahead, guys. I don't want this silence, otherwise I'll pick it up from my side. Okay. Uh, Triveni, what's your opinion?
Uh, Statistics is a kind of measurement, like whatever the existing data. That's what.
Right. So see, you know the answer. Why you were not responding then? Okay. So you said that's a appropriate word. You said measurement. Okay, measurement of certain things. Okay, calculation is different. Okay, measurement is different. So here you are measuring certain things. So definitely there would be certain measures, okay, statistical measures which you will measure to understand a particular state. So statistics in a nutshell is nothing but study of a state. So it has come from a geek word. Okay, when you sorry, status plus sticks. Okay, uh, so this is known as state, and this is study. Okay, so study of a state, a particular state, is known as statistics. Now you can link this particular thing, to any of the things, which you have encountered where you have heard this word statistics. So for example, census, right? When we talk about the census, there people mention all the statistics, like what could be the employment rate, what could be the poverty rate, what could be the GDP, and all those things, right? So 5 year census and all those things. So what they are doing is they are capturing certain amount of data. Okay, they are doing some surveys, they are taking out some samples, and based on that they are making doing some analysis, and from there they are deriving these statistics. Now when we talk about we talk, right, when you take the statistics, okay, when you compare the statistics, you will find that we are doing better than last year. Okay, so what is that statistic? So statistics has through statistics we have studied the last year patterns and this year pattern, and then when we compared, we have found that okay, this year we are doing performing better. So when we are saying statistic, then definitely there has to be some measures which can be compared, right? Now there's lot such measures are there, which you need to which you can consider based on what you want to analyze, what you want to compare, and then accordingly you can make your you can take the decisions, or you can make that kind of statement. Okay. Now, one second. Right. Now, when it comes to mathematics, so this it is not a separate field. Statistics is, you can call it as a discipline of mathematics. Okay, because in statistics also we do a lot of calculations. So here also the mathematics is required, but it is a subset of mathematics. So, but here there are certain in statistics, there are certain kind of measures, okay, certain kind of techniques, certain kind of methodology we follow, to perform a certain kind of analysis. And through this statistics, we can get some idea about a particular state. For example, how a particular economy is uh, uh, of a country is, okay, and how a particular business is performing. Okay, if you want to analyze or if you comment anything about the state of a particular entity, then you can use this statistics. Okay, so once we move forward and we understand about this about further about the statistics and its measures and the techniques and all things, you can relate lot of things. Now, you might have heard about surveys, right? Yes or no?
Yes,
What do
sir.
you, what do you mean by survey? Come on, guys. Everyone might have heard about survey. Customer survey, market survey, all those things, right? So what is this survey all about?
The impression of situation or product.
Okay. Any
Getting
other
the
answer?
getting the customer's opinion of the product or something like that.
Exactly. Exactly. See, most of you guys know the answer, but somehow, you're not responding. Okay. So please respond. So once I'll say that, okay, it's the right answer, definitely you will get more confidence. And the next time again, you will respond. Okay. The people who are not responding correctly, still, they should go and respond, because today possibly your answer may be wrong, but tomorrow you may give the right answer. So, but don't have that fear. Okay. Um, interacting. Okay, start be more active in the class. Okay, so see, survey, generally we go with a customer survey, and as you rightly mentioned, it's all about finding the opinion. Okay, so you might have seen that customer surveys. So you go and include some specific questions in the survey to understand the state of mind of that particular customer. Okay, or to understand a particular state of the market or the customer behavior. So it's not just we take this survey and put it. Okay, we after that we collect the data from the survey and do a lot of statistical analysis on top of it. So we say that 20% of overall respondents, okay, they said that okay, they like smartphones. So now with this statistics, we understood that in the sample, okay, with on whom we ran this particular survey, out of all the responded, 20% of the people, they said that okay, they like smartphones. Okay, or they carry smartphones. So in that way you will understand what is the state now. Okay, what is the state outside, and this kind of information would be helpful for the businesses and even for the governments and for any other institutions to take, or to understand, or to come up with some kind of action plans. Okay, so like that, lot of surveys are being will be conducted internally in the business as well as externally, to understand the state of the market outside or the state of the organization inside. And based on that, lot of meaningful decisions or the actionable insights can be driven, from the data, so that you can tackle to a particular problem, much more effectively. Okay, so now let's suppose if I want to decide whether I should go and launch a particular kind of smartphones or not. First, I need to understand the market trend, what people are thinking about. Okay, and after that only I should take a decision whether I should go and invest or should I go and build those kind of products or not. Okay, so back so it is a very niche subject, guys. And again, it is all uh, based on mathematics. So it has certain set of rules, certain set of measures, set of techniques in statistics, which we will follow to bring out a lot of insights from the data. Okay, which will explain us a state, the condition of a particular state. Okay, so now moving forward. So generally, okay, as I mentioned, it's all about data. You need to have a data, and on that you can apply statistics. So when you are doing a survey, you are capturing the data first, and once you have the data, you convert that survey results into a proper data, and then you can apply a statistic so that you can start understanding the state of mind of the people or the respondents. Now, I mentioned there are certain measures in statistics. Now, these measures could be related to central tendency and should could be related to dispersion. So, what are this central tendency and dispersion? So, certain measures are grouped under central tendency measures. For example, mean, median, and mode. So these are the measures. And these measures you will only hear in statistics, okay, nowhere else. So what is mean? It is nothing but a simple average. Okay. As I mentioned right in the beginning, you guys would be using the statistics knowingly and unknowingly, some or the other way. Most of the time we use average. Can somebody tell me where exactly we use average? Average, you know, right? What we take average, we calculate the average of most of the things, right? But why we calculate average?
Average runs, average score, average marks.
Yes, but why we go with average?
In order to find out how it is performing.
Right. See, when you have to make some kind of a you have to take some guess, wild guess. There you will go with an average, right? If I say, if I ask you, how much you spend in a day, so you will not respond to me that okay, in the morning I'll spend this much, in afternoon I'll spend. You will say on an average I'll spend around 20,000, okay, in a day, right? So what you are doing, you are just taking a guess, indicative way, to respond to me. If I say, if you're running a business, I will ask you how much sales you do in a day or in a month. What you will do? Again, you will take an average. So it is a one way of explaining your business or the state. Okay. So state is like your state of expenditure, your state of sales. Okay, how much you are making, and this is a one simple way of going and calculating and then responding to that particular answer. So even when we are developing our dashboards or reports, what we do is we aggregate all that thing and we calculate the average. This is the average sales in the last quarter. This is the average sales in a month. This is the you can also go with the total sales. But total sales, what it will do is it is more of a specific value for a particular day. But if I say how much sales you do in at any given day, okay, in that case you have to come up with some indicative number. How you will do? You will take the values of certain days and then you will aggregate it. Instead of total will not give the right picture, right? If you make the total, then it is giving you the total aggregation of all the days. Then for a single day, what you will do, you will divide it with by number of days to calculate the average value, and that would be an indicative or estimate about the sales at any given day. Okay, so that is mean. Okay, in statistics, that average is called as mean. Okay, so it is, these measures are like three M's. Okay, when we say central tendency measures, mean, median, mode. And I hope everyone have might have come across these three measures sometime in our school days. Okay, so we have might have studied about mean, median, mode. Right. So now coming to median, what do you think? What median is? Sorry.
Middle value.
Yes. So where do we use median now? I'm just testing your statistical knowledge. That's all. So that you can recall what all you have studied in the past. So median, that's correct. That's middle value. But where exactly we use median?
Maybe the average height based on region wise or
Hmm.
so.
Okay. Okay. So we'll come to that point. So yeah. So median is also other way of understanding a particular state, and then we have a mode. Okay. So we will go one by one in detail to understand what are these. But why we are calling it as a measures of central tendency? See, why we are calling as a measure of central tendency is because these single number itself will describe the complete characteristics of the data. As I mentioned, the statistics is all about describing a particular uh, state. Okay, it's a study of a state. Now you are capturing a data something like this, okay? For example, day one, sales 1,000, day two, 1,500, day three, 1,200, day four, 1,000, again, five, 2,500. Like this, you are capturing. Now I want to understand, as I mentioned, okay, I want to understand what could be the sale for a given day. Then what you will do is you will understand what is the so if I ask you this question, okay, this is what your sales looks like, okay, in the last 6 days or 5 days. Then if somebody asks you, unconsciously you will go and say that by looking at the numbers, it would be somewhere between 1,500 to 1,200, something like that. But how are you arriving to it? If there is any scientific way of describing this particular data, then what you will do is you can consider these measures of central tendency and you can calculate one single number which can describe this entire data. So in this case, you will look out for a middle value. Okay. Again, unconsciously, you will look out for the middle value. Now, middle value could be an average, could be a mean, could be a median, or could be a mode. Okay. You cannot go and say that on a given day, the sales could be 1,000, because there are certain days where the sales even went more than 2,000, like 2,500 or 3,000. In 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 certain scenarios, let's suppose you may have also got a sales of 3,000. You cannot even say that, okay, in a given day, the sales could be 3,000. Why? Can you tell me why? Why you can't say 1,000? Why you cannot say 3,000? Would you respond by saying 1,000 or 3,000 if somebody asks you what is the average sales and this is how your 6 days sales are? Would you go and say 1,000 or 3,000?
No, sir.
No, right?
These are
You
the
will not say.
extreme values, min and
Yes.
max.
These are extreme values, and this we also call as an outlier. So see, sometimes your sales may go very down. Okay, it may be like 500 or 200. Okay, sometimes your sales may be very high, like okay, 4,000 or 5,000. But if somebody asks you what are your typical amount of sales you get in a day, generally you will not say these extreme values, because this is once in a while, you are getting such kind of scenarios. You roughly what you will do is you will concentrate in the center. Yes, because in the center, these are the scenarios where, most number of the times these kind of sales you have seen. Okay. So in that case, you will look out for one central value or middle value, which is like very safe for you to respond. And that would itself, uh, would describe the entire set of data. So why we go with the central value? Because there would be less risk of going wrong if you pick up the central value. In statistics, it says that okay, your entire data is the weight of the data is kind of being balanced centrally, which is captured by these three measures. Okay, which is mean, median, and mode. Okay. Now, where to use mean, where to use median, where to use mode, okay, that's something, okay, we will understand, when we discuss about different kind of scenarios. So measures of central tendency yield information about the particular place or location in the group of numbers, which could describe the characteristics of the set of data. And these central measures are mean, median, mode. So when you take the average of all these numbers, you will find a number something like 1,800 or 1,900, which will show you the place, which this 1,800 will come somewhere in the center of the data, there where you will find enough number of data points above 1,800 and you will find the enough number of numbers above 1,800. Okay. So in that case, the 1,800 will be considered as the central measure of this particular data. Okay. Now so we have seen that mean is one such measure where we will take the average. But again, there is a problem with mean. What is the problem with mean is when you calculate the mean will give importance to every value in your data set. So, for example, a very rare scenario, one day you got a sale of 13,000. Now, if you take the average, now this particular mean will shift towards this, will get influenced by this particular value, 13,000. Okay. Now, if you go and add 1,000 plus 1,500 plus 1,200 plus 1,000 plus 2,500 plus 13,000, you will get an average value of somewhere, 8,000 or 9,000 roughly. Okay. So your mean has shifted to this side. Now your mean is here somewhere. Now, in this case, your mean is not the right measure, which will explain this particular data because you have a extremely high value on the right and the mean is sensitive to every value. If you have more extreme values in the data, then you should not go with mean. You should not go with an average. Firstly, either you should go and treat your outliers, you should identify and drop those outliers, then you go and take the average. See, average is only works well where most of the values they are kind of on a similar scale. If you have certain values which is altogether in a different scale, different if it's too much of difference in that those values, then in that case, mean is not the right measure, to explain the data. Okay, then we'll go with the median. Okay, so summary. So this is right when you are describing the data, when you are studying about a particular state. So now here I'm studying about the business sales. Okay, so I want to understand the state of my business sales. So in that case, I'm going and using this mean, to understand what is the average sales per day. But if I encounter some extreme values, then again, this mean is not the right measure to go ahead with this. Then I will go with median. Okay, so we'll discuss about median later. So what we are doing is I'm kind of understanding the state by using these measures. So these measures are also called as summary statistics. So when you have a data and if you have to describe that data, you use this summary statistics or these measures to understand how your data is, okay, what your data is explaining you. So that's something you can easily understand through these statistical measures. So, and these summary statistics is divided into two parts. One is like central tendency and second is the dispersion. Central tendency will help you to understand where your central location or where the entire mass of your data is located. Okay, that you can identify through mean median mode. Okay, it's just like fulcrum. Okay, if you have a data, if you have a weights, okay, and you want to balance that weight, so what you will do, you will find out the central point of that particular weight and you will try to balance that weight. So for example, you want to balance the book on your finger, right? So you will try to find out the central point of that book and you will try to balance that on your finger, right? So in the same way, in the data also, to explain about the data, we will try to find out one central position which can explain me about the data. If I say, just take a scenario, okay? In your class, in this particular class, let's suppose I want to understand what is the average age of the student. Okay. So here, if I'm seeing a person with, you know, more than 13 years experienced guy also coming and attending this class. And if I see that the person who have just passed out from graduation, they are also attending the class. So here there are too much of extreme values. Okay, in that case, average possibly could not be the right measure. But if I go to a 10 standard class, okay, and then there I will go and ask what is the average age. There is not too much of extreme values, right? There the mostly the age groups would be very much closer. Okay, and there the average is the perfect measure. Okay, and I can get the right answer there. So few people would be 10th class would be how much? 16 years. 16 years, 16.5, 16.2, 16.1. So there the average would work perfectly because I do not have extreme values. So you need to decide which measure to use in which kind of scenario, and by examining your data of a particular state, you can choose the right measure. So now the central tendency can be explained through arithmetic mean, which is nothing but your average. Could be a weighted mean. I will explain you what is weighted mean, and then the median or the percentile or the mode. But typically we go with mean, median, mode. I'll explain you about the percentile as well. Okay, so these are the measures of central tendency. Thus now the second measure is dispersion, okay, which we'll discuss in more detail. So for example, as I mentioned, okay, in this class, what is the age? So firstly, to understand this particular data, I may go and understand what is the minimum age, what is the maximum age, right? And then I will calculate the range. So let's suppose range may be somewhere from 22 years till 35 or 40 years. Okay, so I can get some idea about the state of this of this class, right? So if I want to understand more about it, then I will go and use some other advanced measures. Like I will go with standard deviations, I will go with variance to understand how the values are varying, okay, in my data. So dispersion is all about how the values are dispersed in the data. So if my business sales is 1,000, then 12,000, then 15,000, then again 1,000, then again 2,500. This is one scenario. And the another scenario is I'm getting 1,000, then 1,200, then 1,300, then 1,250, then 1,320, then 1,400. Now you tell me which business is more stable, guys? This one or this one? I'll mark it as A and B. Which one you think is more stable business?
B.
B.
B, right? So see what you did, how you arrived to this particular answer that okay, B is more stable.
All the
Difference.
values are nearby.
So basically, there is less dispersion in the values. The values are not varying too much, right? So how you will, so there is a statistical measure, okay? You can directly calculate that measure and you can understand how much is the variance. Okay. Now here it is kind of looks very unstable. Sometimes 1,000, sometimes 15,000, sometimes 2,500. Here the variance is high. So if you want to uh, share a report to your stakeholders saying that okay, the business in 2022, was very unstable, and in business in 2021, the business was stable. How you will quantify? This is very qualitative statement what you are doing, what you are making, right? I'm asking you why you feel that business B is more stable, then you are saying the values are very closer. So when you go to the business, you cannot answer in this way, right? You cannot put this kind of report, the values are very closer. That's the reason we are commenting that business B is more stable. You have to quantify. You say that the variance in year 2021 is less while compared to 2022. That's the reason we are saying that business in year 2021 was much stable than compared to in the year 2022, 21. Okay. So that's how you can use these measures to understand how the data is varying. And now this again may lead to a lot of different insights. So for example, you want to invest into a particular stock. Okay. So let's suppose again we'll consider like these two scenarios where this is the stock price of stock A and this is the stock prices of stock B. Now you tell me where you will invest. Stock price A or stock A or stock B? Guys,
B, sir.
stock price B. Okay. So someone is telling they will invest in stock B. Everyone agrees? The stock B is a good choice. Okay. So there's again no right and wrong answer. See, now if you are more risk averse, okay, you want to go slow, you don't want to, lose a lot of money. So there you can go with a stock B, where the value, the price of the stock will not vary too much. Okay, so it will maybe very um, little bit of increment, and over the period of time, you may expect that okay, you may get 5% or 10% of the returns. Okay, so in that way, you will go with a stock which is not much volatile. Okay, but few people are like risk taking. Okay, now the stock price is just 1,000. Let's suppose in next month it reached to 15,000. Just imagine, okay, how much returns that person will get. Okay. So again, on the variance also, people will decide which stock to buy, right? So few people to make a diverse portfolio, what they will do is they will invest in certain stocks which is having less variance, and certain stocks, which is of high variance, and they will allocate the amount or the investment amount in such a way that okay, they will put a certain portion of the data, a certain portion of the amount in a high volatile stocks, and maximum amount into the less volatile stock, so that they can diversify the risk. Okay, so in every scenario, this is helpful to understand how the values or how the data is varying over the period of time. Okay, that you can calculate through this dispersion measures. So you have multiple measures. We will talk about skewness, kurtosis, range. So all these are measures related to the statistics, which will help you to understand the data. So that's the reason we call it as a summary statistics. So even when we have to go and train the model, okay, machine learning model. So firstly, we will go and analyze the data. We go and calculate these summary statistics to understand the quality of the data. If in my data the values are varying too much, so that means there is too much of variance, and that possibly may not be good, for my model training. Okay, and sometimes we need high variance data so that we can capture uh, the different scenarios, and we can able to come up with a better model. So understanding the data is very much important, and that you can only do through these statistics. And after analyzing the data, you can further go and proceed with your further advanced analytics, or such as training the model. Okay, so let's first discuss about mean. Mm, okay. So commonly it is known as mean, and in statistics uh, we joke and we say that okay, mean is always mean. Okay, because what happens is like if the mean is, because mean is very sensitive, right? So wherever there is extreme value, it will go towards that. So that's the reason we call mean is always mean. Okay. So when it is getting impacted by the extreme values, then this is not, as I said, this is not a right measure, to rely on. Then we will go with some other measures. But what it does is it only just calculate the average of the group of numbers, and it is applicable only on certain type of data, because these average you cannot calculate on the categorical columns. You have to calculate only on the numerical columns. Okay, so we will talk about what I mean by categorical, what I mean by numerical, what do you mean by interval and ratio data, okay, in some time. But just to understand, okay, this arithmetical mean can only be used on the columns which captures the numerical values. Okay, because you cannot calculate the average on non-numerical values, right? Uh, and as I mentioned, it is affected by each value in the data set. So now let's suppose you have a data, something like that, and you have one extreme value. Okay, so your average would be different. If you remove this, then your average value would be different. If you remove any value from your data set, your average will get affected. Okay, so that means your mean is sensitive to extreme values, and it gives importance to every value in your data set. Okay. And you know how to calculate this. You sum up all the values in the data set and divide by the number of values in the data set. So this is the formula. And see, in the statistics, if you are referring to any book, okay, you will find certain notation. Yes, we can say that it is very sensitive. So here, again, you have to be very much clear with these notations. Okay. I'm talking about population mean here. Okay, so I'll tell you what do you mean by population, what is sample. Statistics is all about sample, guys. All about sample. Okay, so to differentiate a mean as a population mean or as a sample mean, we denote it with different notation. Okay, so when we are talking about population as a whole, so what is population? What is sample? So population is something like every unit, if I'm considering, okay, then it is called as population. For example, if I say, what is the average student age of class 10 standard? So if I have to, and if I say in Hyderabad, so what is the population? In Hyderabad, I have to go and look out for every school. In every school, I have to go and refer to the 10th standard. And if I go and calculate the average, then now that is known as population mean. So what I'm doing in this particular Hyderabad, if I'm going and referring to every entity, every school, and that in that 10 standard, then I'm covering the entire population. Okay. So in that case, it will be denoted as mu. But do you think it is viable? Or do you think it is easy to do that? It's not. So that's the reason we go with a sample. So what we will do, and there is a different ways of generating the samples. I may go to the nearest schools, or I may go with certain number of government schools or certain number of private and international schools, and then I will collect the data from those schools and create the sample, and from that sample I'll calculate the average. Okay, so and we we will believe that, okay, whatever value we are getting out of the sample would relate to the population. See, now during the elections, you people conduct surveys, right? And they will say that, okay, during this exit polls, we found that, okay, 80% of the people, they are going to support BJP. It doesn't mean that, okay, they have went every door by door in every house and checked with every person, whom they are going to vote, right? So they will take the sample, they will make the survey. Survey is always done on sample. Okay. So they will go and understand from different age groups. Okay. They will go in different locations, different community, and they will try to understand, what is the pulse of the people. And based on that, they will gives some kind of indication. And this time, see how accurately they have given the statement. They said Congress is going to win, and nobody ever thought of like Congress will win, right? This time. But the survey was 100% correct. Okay. And that's how, it was very much closer to the entire population. So statistics, firstly, it will explain the state, and that too with a smaller data, okay, with the sample data. And with that sample data, whatever you insights you will derive, if you can relate it to the population, then lot of your money and efforts and time will be saved. Okay, so if I understand through my survey that, okay, people are going to like the smartphones, and I can think of some innovative smartphone and I can go and launch it in the market. Okay, so that is the power of the statistics. And we will understand how through this statistics, we can relate the sample statistics with the population parameters. Okay, so this is a population parameter known as population mean, which is denoted by mu. Okay, this is known as mu. Okay, so now mu is like collecting all the points from the population and then finding out the average. Okay, that is mean. So this is highly impossible if your population is big enough, and difficult enough, to capture. Okay, in that way, the population mean you cannot calculate. You can just refer to mu. Okay, so just for now, just understand that in statistics, mu means population mean. Okay. Now comes the sample mean. So sample mean is denoted by X bar. Okay. So where you will have small samples and every value, if you consider from that sample and find out the average, then that becomes your sample mean. The formula is always the same. Okay. It's the sum of all the values divided by number of values. So that is the sample mean. Now, before getting into next topic, okay, let me explain you why we go with population and sample. So now let's suppose this is population. And guys, stop me anywhere if you have any confusion because this is important for you to understand. Okay, if you don't understand, rest of the other topics would be hard for you to understand. Okay, so for example, population. So what happens in population is so population in population what happens is first of all, it's difficult for you to even identify what population is. What is the size of the population? As I mentioned, if you want to find out which political party will win, okay, in this particular election. Now, what is the population? What would be the population? Shall you would you go and consider the entire India population or whoever has the voting rights to understand which party is going to win? So in that case, you just imagine how difficult it would be for you to go and analyze the entire population. Okay, if you want to find out uh, what is the average, again the average sales of the business, then since the inception of the business, if you are considering all the data points, and it becomes a population. You will go here, for example, it's a 10 years old business. So for in 10 years, every day, okay, what is the business happening? Okay, then if you are considering, then it becomes again difficult. You are considering the entire population. So sometimes it would be difficult even to draw the boundaries like what would be the population, right population. And sometimes, to handle the entire population is difficult because there could be lots and lots of data and it is not feasible or easy to capture the entire population. So what to do in that case? How to move forward and how to do any kind of analysis? So there comes the statistics. What the statistics will do is it will not it will not take the entire population into consideration because it is difficult to do any kind of analysis on the population. So what you can do is you take the simple sample. Okay, the sample is nothing but it is a subset of the population. But while coming up with a sample, you have to make sure that it should describe the entire population. It should represent the entire population. Okay, so if this is your population, now this should be a sample. It should not be like you just took this part of it. Okay, now considering it as a sample. So what will happen is then you are becoming biased. So if I'm talking about the India, then if you go and just perform your survey in the North India and you if you don't consider the rest of the India, then again you are becoming biased to a particular community or particular part of the India, right? So if you want to go with the right sample, then what you will do, you will consider certain people from North India, certain people from South India, East, South, every part of the India, and then you will take some 100 to 200 people which represent the entire India population, and then you can go and conduct your survey. Again, if you want to, if you are targeting every age group, and in your sample, if you are just considering a particular age group, then again it is not right. Then you have to go and consider the sample in which you have, in which you have kids, even in which you have senior citizens, in even where you have certain adults, people, teenage people, and then you can go and perform the survey. So after understanding what is the problem statement, what you are going to analyze, uh, you have to choose the right sample. So, but this population has to be a clear, this sample has to be a clear representation of the population. Now, for example, on this population, I want to calculate the average. So, which we have just seen is denoted by mu. But due to many reasons, I cannot calculate this mu because one reason is the data could be very large or it is highly impossible to collect that data. Okay, if I say what is the average income of people in India of age group 20 to 25, okay, so how difficult it would be? Like I have to go and identify every person in India with age 20 to 25, rural, urban, everywhere, okay, in all the cities, the people who are educated, the people who are not educated. I will go and look out for every entity and then I have to go and calculate the mu. So this is highly impossible. Okay. Then what I will do is I'll find out some sample. In sample, what I will do is I'll put my person, in different places. I'll say, okay, collect values from the rural population, from the urban population, from different cities, from different regions of India, and then I can go and find out the average income. Now that would be your X bar. Now, what is this X bar? It is a indicative representation of this mu. With this X bar, I can get some idea about this mu, and then I can make certain comments or certain decisions related to this particular population. Here, my aim is, to understand the population, to understand the state of the population, and then I want to make the decision which could help the population, to solve a particular problem, right? But the first bottleneck is I cannot analyze the entire population at a whole because of multiple reasons. So for that, what I will do is I'll take the sample and analyze the sample, and based on the sample, I will go and calculate certain measures and which would be the indicative measure of the population. Based on that, I will get the idea about the population and then I will take the decisions related to that particular population. So I'll give you one more example, then you will get better idea. So for example, I want to maintain the quality standards, okay, of my product. Okay. So I'm producing millions of products, okay, units in a day. Okay. Now I have to measure the quality standards, whether my quality standard is 90% or 100%. Okay. Every time I want to measure it. Now you tell me, is it feasible to go and check the every product, every unit, okay, whatever I'm producing and calculating the quality of it? No, right? It's not possible. So even when some audit is happening, even the auditor, what it does is, or the quality inspection happens, what they do is they will take the sample. They will take the sample and then they will analyze that sample, and that sample will give you certain quality measures. Sometimes, let's suppose I reached 90% quality, sometimes 100, sometimes 95, sometimes 98. So this is my sample. Then on an average, let's suppose I am successful in meeting 97% of the quality standard. Okay. Now with this measure, I can relate to the entire population. I can say confidently that my plant or my company is meeting 97% quality standards all the time. Okay. But sometimes if I'm meeting 60%, 40%, 80%, okay, 90%, then my average will also get affected. Okay. And that's how, I can say that, okay, my quality standard is not stable. Okay. So through sample, I can analyze my entire population and I can decide what needs to be corrected on my entire population and what kind of decision I need to make on the entire population. Okay, so that's the reason this statistics plays very important role on quick analysis, on quick decision making. Again, one last example in the life sciences. Now, we have gone through this difficult phase of COVID, right? During that time, there were no vaccine, and it was a big challenge for these pharmaceutical companies, to come up with a vaccine. But again, let's suppose they have come up with a vaccine, they have to test it, right? Whether it will work on the entire population or not, right? So what they will do is, what they have done is, they took a sample. So first, like if somebody has some understanding about this license, how it goes is they will go through some multiple clinical trials. So what they will do is first they will not go and try it on human beings. They will first try it on some creatures, okay, some animals, and they will test the results. And then if it is successful, again, they will not test it on uh, every animal. Okay, they will take some sample animals, okay, which are very much similar. Their anatomy is similar to human beings, and they will test it there. And if it is successful there, then phase wise, they will conduct multiple clinical trials on various age groups. Okay. So again, are they trying on every person in the population? No, right? They are taking some sample, some few people, and then they are applying on it. Whether the results of all the clinical trials are same? No. Then what they will do, they will take the average of the success rate. If the success rate is 99%, then they are confident. Okay, there would be a certain guidelines that if your clinical trials is passed more than 99% or 98%, then you are then you can go and launch your, or you can sell your product. Okay, sell that particular drug. So so that's how, through this statistical measure, through this statistical technique, you can just take the sample, small sample, you can make certain experiments, and based on the experiment results, you can go and testify, or you can go and release it to the entire population. So in every domain, in every way, okay, in every business, the statistics will help a business a lot, to quickly analyze the data. With a small amount of data, they can take much more strategic decisions. Okay. So I'm just talking about mean because mean is a very quick way of, understanding a particular data. Okay. So, and most of the times we just say on, we say that how much time does it take, for you to reach to your house, okay, from your office. If I say, what you will say, you will take average time only, right? Most of the time, most of the scenarios, we generally go with an average. So what you will do, okay, so in your mind, you will say that, okay, in the last 3 days, roughly it took me 35 to 30 minutes or 40 minutes. Then you will take some middle value and you will say that is the answer. But in your mind, whether it is a median, whether it is a mean, you don't know. Okay, but you generally, you will on the fly, you will say, okay, 30 to 35 minutes. Okay, what you say. Okay, either you, sometimes you will say the range where you will take the minimum time and the maximum time. So there, what you are doing, you are describing it by dispersion measure. You are giving the range. I think somewhere between 20 to 40 minutes. Okay. Sometimes you will come up with a very specific number. Okay, somewhere around 30 minutes. Okay, how you have derived that? So unconsciously, what we are doing is you are going with mean and a median. Okay, and you are explaining that. And the business also wants such kind of an indicative value so that they can make a better decisions. So that's use of these statistical measures. Now moving forward, now we have a weighted weighted mean. Okay, so I'll just skip this slides. Now you have a weighted average. Okay, so what is the weighted average now? In some of the scenarios, you will give some weightage to certain values. Okay. So for example, you have a data, and in that data, you want to give higher weightage to the values which are greater than, let's suppose, 2000. There could be some scenarios, okay, like that. For example, uh, when you are measuring the quality standards, then let's suppose your aim is to achieve higher quality standards. Then whenever you are not meeting those quality standards, you want to give more weightage so that your overall score should consider those scenarios with higher weightage where your quality standards were low. Why? Because in that case, you will strive hard, to even further maintain the higher standards. So what you're doing is purposefully is like, for example, 70% you reached one time, you reached the quality standard, sometimes 60%, and most of the times you reached 98% or above 90%. Now you will give higher weightage to, because these are very important for you, and you will not just ignore because out of 10 data points, these were only two times, where I missed the quality standards. But as a business, you want to give more emphasis to these points or these values where your quality standards were below 80%. Then you will give more weightage to this. Because if you give more weightage to this, then the over average value will not be more than 90%. Okay, it will be somewhere 80% or 85%. In that way, you will always focus on those observations where your quality standards were down. Okay. So in that case, you can go with a weighted average where you're not giving the equal importance to every value. In the average, what you're doing, you are just taking the sum of all the values. So all the values are having a equal importance. But in the weighted average, you want to give a more importance or more weightage to certain values. There you can go with a weighted average. So weighted average is the sum of dot product of the values and the weights divided by total weight. Okay, that is known as weighted average. So these are the different versions of means. So weighted mean or normal mean, arithmetic mean. Okay, and based on your scenario, you have to go and choose the right appropriate measure, which can help you to understand the state of a particular, the condition of a particular state. Okay, so now for example, this example. Suppose there is a midterm test score of a person is, let's suppose, 83, and the final exam score is 95. Now, there are two scores. One is midterm, second is the final exam. Now, guys, definitely, okay, more weightage needs to be given to the final exam only, right? Midterm, because less portion, okay, not that serious. Okay, so weightage would be relatively less than final exam. Now, based on these two scores, you have to calculate the grade of that particular person. Okay. Now, I'm going with a weighing criteria here, saying that 40% weight should be assigned to the midterm exam and 60% of the weight should be assigned to the final exam. Okay. Now, I have to go and compute the weighted average of this course. And based on the average score, I will go and uh, give that person a grade. Now, this is how I will go and calculate the weighted average. I will multiply the value with the weight, 83 into 0.4 plus 95 into 0.6. And then I will sum the entire weight, so 0.4 and 0.6. So now this is my weighted average. Normal average, how you will calculate it is 83 plus 95 divided by 2. Now this would be different value, and here it is a different value. Now, based on this, if I'm saying that if the minimum average for an A grade is 90, and if anybody is scoring above or equal to 90, then they should earn a grade as A. So here this person is having a weighted average score is 90.2. So that's the reason he will earn a grade as A. So that is how you can use this weighted average. It's a very simple example what I've given, but in the real scenario you will be having a lot of values, and you have to put a condition saying that if the values are below 80%, then the weightage should be this much. If it is below 50%, then the weightage should be this much. So and that's how you can add more penalty to the values which are very low, and then that's how you can come up with this weighted average, which will give you the clear indication about your data. I'll take a pause. Any questions till now? You understood the mean and the weighted mean? Everyone? Yes or no? Okay. Okay, so fine. So I'll move forward. So see, very small, very simple measure, but gives lot of insights, right? Now comes the median. Median is what? It is the middle value in the ordered array of numbers. Now, as I mentioned, if your data is having extreme values, the definitely mean will not give you the right picture. Okay, and it may give you a wrong output. Okay, which you cannot rely on. So in that case, we will go with a median. What median? How would you calculate the median is first you have to sort the values. Okay, so for example, my business sales. So minimum it is, let's suppose, 1,000, and I sorted the values. Sometimes I got 1,200, sometimes I got 1,500 sales, sometimes 2,000, 2,800, 3,000, something like this. And I'll take few more observations. 4,000. It is not in a chronological order, but I have ordered my sales. Okay, so minimum sales I got 1,000. Okay, and the maximum sales I got 4,000. Okay, so now to either I can go with an average. I will take the average value. Okay, it may give you some value somewhere here in the center. Okay, it may give me a value as 2,700 or 2,900, something like that. Okay, so that would be my mean. If I go and calculate the median, so how many values I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1, 2, 3, 4. Yeah, so this would be my middle value, 2,800, right? So I have four values on the top, four values below. So this is a central value. And if you're seeing, if there is not too much of variance, even my mean is also somewhere here. So my mean would be somewhere here like 2,900 or 2,700, something like that. So if your data is properly distributed without too much of variance, then mean and median also be equal. Will be equal. Okay. So even that property we will understand what we call in statistics. We call it as a normal distributed data. Okay. But if you have extreme values, let's suppose if I make it as 14,000, definitely my mean will shift here. Somewhere here it will shift. Okay. So it will not be anymore in the center. My mean will be here somewhere. But my median will be here only. Still it is a middle point, right? Still median will be 2,800. So still I have four values on the top of 2,800 and four values below 2,800. Are you following, guys? So mean is sensitive to the values, but median is not. Okay, median only if you add one more observation here, then median would shift here below. But until unless if you're taking the same set of observations, then median will be not impacted if you are changing the values of any observations. Okay. So now median again we will use in certain scenarios. One is like if there are not extreme values because it is unaffected by extremely large and extremely small values. Even if you make it as 100 here, okay, this median will not get impacted. Okay, so the mean will shift towards further down. Okay, if you have 100 here, okay, so the mean will get affected, but the median will not get affected. Okay, so if you are going with a count, so where, for example, in a particular class there are 30 people. Okay, uh, so let's suppose 15 people are having an age more than 21 and 15 people age is more than less than 21. So then 21 is the center value, and instead of going and calculating the average, you will better go with 21, and you'll say that okay, 21 seems to be a right age, for this particular class, and that I will kind of consider that as for even for a entire population also. Okay, so computationally, how you will do is you arrange the observations in an ordered way, either ascending or descending. Okay, and then if it's an odd number of terms, then the median would be the middle term. Okay, so just now we have seen, right? So how many we were having 9 observations. So in that case, it would be the center position. If it is even number, for example, 8 or something, then you will have two numbers. For example, I'll just take a simple, okay. So I have only four numbers. So here I don't have the central value, but where exactly the central value may locate? Here, somewhere here, right? But I don't have the value. So what I will do is I'll consider this value and take the average of these two values. That will become my median for even number case. So 1, 2, 3, 4. How many number of observations, how many number of values I have? I have four number of values. In that case, I will take the two central values and then I will take the mean of it. That becomes the median. But if it is odd number of values, then it is simple. Okay, if you go and just find out the central value. Here it is the fifth value, where I have 9 number of observations. So 4 will be on the top of this fifth observation and 4 will be down of this fifth observation. Then in that case, this fifth observation will become the median. Okay, so if there is an even number of terms, the median is the average of the middle two terms. Second, mathematically, median position is an order relay is given by n plus 1 by 2. Okay, it will give the position of the median value. Okay, let's take the example. Let's suppose I have these values. So this is an array. From one unit, I've calculated the value, which is coming out to be 3, second time 4, 5, 7. So these are all the values, and I want to calculate the median of this particular array. So there are 17 terms. So 17, first you have to check whether it is an even or an odd. Okay, it is a odd value. So mathematically, how you can calculate? Take this number of terms plus 1 divided by 2. Okay, it is giving me 9. So 9 means ninth position value you can consider as a median. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my middle value. Okay. So below this, there are 8 values. Above this, there are 8 values. Okay. So overall, it is having 7. Overall, it is having 17 values, in which the ninth value is the central value, which I can consider as my median, and I can go and uh, take the decision based on this particular value. Okay. Now, if you see, if the 22 is replaced by 100, so here if I make it as 100, would my median change, guys? Will my median change?
No.
My median will not change because it is based on the position, right? Still, my position is the ninth position and it is 15th. So still my median would be 15. If I replace 3, okay, this value by -103, still it will not be affected. But will my median will get affected? Yes, my median will get affected. If I make it as 100, then my mean may shift this side. Okay. If I take the lower value, then my mean may shift this side. So my mean will get sensitive, will become affected by the extreme values. It could be on either side, extremely small or extremely large. Okay. So finally, the mode. Okay, what is the mode? Can anybody tell me before I'll show you this particular slide? What do you mean by mode? Anybody has any idea?
Frequently occurred value.
Frequently occurred values. Perfect. So frequently occurred value. Okay. So when I say frequently, can you tell me, can we use this for describing sales data? What do you think?
Yes.
Yes?
Yeah.
Okay. So if I say my sales is 1,000, 1,200, then 1,300, then 800, then 500, then 1,500. How you will calculate the mode? Is there any number which is frequently occurring?
No here.
No, right? So sometimes the mode, or most of the times I would say, mode is not a right measure for a continuous column. Continuous column means where the field may take any value. In that case, only you have to go with an average and the median, okay, to describe the data. You should not go with mode, okay. Where the mode will be helpful is, uh, for example, survey, okay, survey only. In survey, let's suppose if I am giving a close-ended questions, saying that, okay, if you have you liked the color of this particular product, okay, rate on the scale of 1 to 5. So for one person may say 1, another person may say 2, then again the third person may say 2, again 2, then 3, then 4, then 5, then 5, and then 5, 5, 5. One thing is like you can take the average, saying that what what people sentiment is all about, how the people are kind of perceiving the color of this particular product. Okay. So you take the average of this and you can say that, okay, now on an average, people has rated this as 3.5. Okay. But let's suppose here one is all about saying not liked. Okay. It is disgusting. Okay. Something like this. Very strong word. 5 is like very pleasant. So I have these 3 or 4, 5 categories, okay, which describes which explains the uh, color of that particular, how the people have perceived the color of my product. In that case, I'll better go with a mode. I'll so for example, most number of people they have kind of like this. So they have considered it as a very pleasant. In that way, business will get a better picture rather than if I'm saying 3.5. 3.5 somewhere is in these two, between these two classes. What again different name you will give to that particular class, right? If it is like uh, okay and fair, okay, something like this. What middle category you will coin? In that case, you will go with a mode. Mode is the most frequently number occurring in your data. So if in your data 5 is occurring more number of times, that means more high proportion of uh, people, they have kind of like the color of the product, and that's the reason I'm going with that. Okay, so that would be a mode. So it will be applicable for nominal, ordinal data. So I'll explain you tomorrow. We'll talk about variables. There I will explain you what is known as nominal variable and ordinal variable. And sometimes what will happen is even you will get bimodal. So what will happen is, so let's suppose there are 7 5s and there are 7 4s. 7 4s are also there. Okay. So you will have two modes now. One is 5, one is 4. Okay. So in that case, the data set will have two modes. Maybe it may have multimodal. Now with that, you will understand the data. Okay. So it will also give you a clear picture. Like if there are multiple modes, then that means there is a mixed sentiment of people. Okay. So there are equally number of people they are saying it is good. There are equally number of people they are saying it's bad. And that means you cannot take any decision on top if it's a multimodal data. Multimodal data is always not good in terms of making decisions, because in that case you cannot arrive to any one single conclusion. So if it is a uni model, if you have only one single model, then you can very confidently you can go and take the decisions. So most number of the people, they like this movie or they like the product or they like the color of something. Okay. So in that case, you can, with a single model, you can go and take a confident decision. If they're multi-models, then it's hard. So once you are inspecting the data, you can understand through this mode how your data is all about. Because here in this case, probably the average and the median may not give you the clear picture. Because see, if you have 4 4 4, if you have equal number of fours, equal number of fives, if you take the average, it will give you somewhere between 4.5 or something like that. Okay, but what conclusion can you derive? Okay, but if you go with a mode, you will understand that okay, there are two modes. That means more number of people, they are kind of stating that this particular product is good as well as bad. Okay, so in that way, the conclusion would be much more easier. Yes. So now whatever we have discussed now, these are all the measures. Okay. Now, as a data science professional, you have to understand where to use mean, where to use weighted mean, where to use median, where to use mode, and then appropriately you have to pick up these measures and apply that on your data and then derive the insights out of it. And when you are giving these insights to the business, you have to make sure that you are using the right measure and you are giving the right insight to the business, because all the decisions will be made based on these measures. One way is like directly based on these measures, they will relate it to the population, and then accordingly they will go and make the decisions and apply, take some strategic decision and apply it on the entire population. Okay, for example, the quality. If I'm saying, if I took the sample and on that sample I found that the quality is not good, then that means, there is some problem with the production line. Okay, probably we are not following the right process. So now the business may decide, to go and revamp the entire production line. So it may be such a big impact also, okay, where the decisions will be made on the entire population. Okay. So for example, I just did some kind of a survey and then found that okay, uh, uh, people are like inclined towards you know watching uh, mobile phones 6 hours or 6 hours a day, and it's possibly there is a research survey that okay, people currently now the screen time is even more than 10 hours. Okay. So if it is 6 hours, then if I want to go and run the campaign at an entire population level, so I have to spend a lot of time. And if I go and launch that entire campaign, if my these results are not accurate, then entire campaign will go for a toss, right? If I go and run this campaign everywhere and everyone can relate to it, yes, even my screen time is more than 6 hours. My time is also more than 7 hours, and people may be interested towards that campaign. But if my this is wrong, if I'm just my sample says that it is more than 6 hours, but in reality people's screen time is less than 2 hours or 3 hours, then my campaign will be a complete flop. Okay, it will be a completely waste of time and efforts, right? So you have to understand what measure to use and how that measure should be perceived, and whether based on that particular measure, the decision can be made on the entire population or not. That's something you have to understand in the beginning, and then you have to choose the right measure, guys. Okay. So nowadays, what happening is in the dashboard, on the dashboard, these are becoming the some of the KPIs which we are showing on the top of the dashboard. Like what is the average sales? What is the average uh, you know sales per product, okay, of any particular product. What is the most frequently purchased product? There we will go with the mode, right? Mode will tell that which of the products are being purchased more often. Okay, who are my top customers? So top customers will also you can capture either through average by looking at how much is the average uh, revenue they have generated for the business, or else you can go based on the frequency. So if you are going based on the frequency, then you have to use mode. So based on the number of transactions, okay, you can able to identify which of the customers are your potential customers who are like buying more of your products. So like that, you can identify some of the um important information which you can derive from the data, and then you can show it on the dashboard. All right. Till now, is it clear? What is the importance of this mean, median, mode? Probably we might not have thought about, how these three measures could be used by the business to make decisions. Just imagine, with this simple measures, I'm saying, a lot of big decisions are being made currently by the business. Okay, so later when we get into dashboards and all those things there, I will show you, what kind of insights we can generate through these measures. Okay, so I'll take a pause. Any questions, guys? Okay, and I will share you the notes, okay, which I have prepared on my own. So I will share you the soft copy. So go through that material as well. Okay, so you will get a lot of theoretical understanding on these concepts as well. Okay, so I'll share it today itself.
Okay. Yeah.
Okay. And one more small request, guys. So tomorrow is my daughter's parent-teachers meeting. Okay, it is exactly at 9. So I have to go to her school. So I may request Vikrant to take a class tomorrow, and he may continue with the Streamlit, or else, we will take an off tomorrow. And if possible, we will take it on Sunday. So please let me know, who all are comfortable, how many people are comfortable to have a class on Sunday.
I'm okay.
Okay, so if you can't decide now, you can just message me on the Telegram channel. So if most of the people are comfortable, then we will not have a class tomorrow and we will have it on Sunday. If most of the people are uncomfortable on Sunday, then we will either Vikrant will take the class or we will take an off. Okay,
Sunday, I'm also okay. No issue.
perfect.
I'm
Okay,
also
so
okay Sunday.
all right. Okay, so based on your response, we will decide. Okay, and we will announce. Okay, we will tell you whether we will have a class on Sunday. Any other questions, guys? The Streamlit class will be again, we will take it. Okay, so don't worry. So it was just, I was not there, so I asked Vikrant, to take some topic on Python. Okay, so it is not covered completely. So I'll ask Vikrant if we can take tomorrow to complete that topic. If not, then we'll take an off. Okay, but Sunday, if everyone is comfortable, I will take the class. All right. So whatever it is, we will inform you on the Telegram channel. All right, guys. Then thank you. Have a nice weekend. Have a nice day. Take care.
Yes, sir.
Thank you.
Thank you.
Bye.
Thank you. Bye.
Okay.